The next chapter which we have is the chapter of complex numbers. Now this is a chapter in which most of the students find some bit of difficulty. But I'll say that if you apply all the concepts properly, this is as easy as the chapter of real numbers. The first problem which we have is we are given that a, b, c up to k are the roots of this equation, and we need to prove that 1 plus a square into 1 plus b square up to 1 plus k square is equal to this thing. Now starting with the fact that a, b, c up to k are the roots of this equation, we can write it as x power n plus p1 into x power n minus 1 up to pn is equal to, since these are the roots, it can be written as x minus a, x minus b, x minus c up till x minus k. Since a, b, c up to k are the roots of this polynomial, now putting x equals iota in this expression, we'll get iota power n plus p1 into iota power n minus 1 up till pn is equal to iota minus a, iota minus b up till iota minus k. Now in taking iota power n common from this entire expression, we get 1 plus p1 into iota power minus 1 plus p2 into iota power minus 2 up till pn into iota power minus n is equal to iota minus a, iota minus b up till iota minus k. Now we know that iota power minus 1 is equal to 1 upon iota is equal to minus iota. Iota power minus 2 is equal to 1 upon iota square, which is equal to minus 1. Iota power minus 3 is equal to 1 upon iota cube, which is equal to iota, and iota power minus 4 is equal to 1. So putting all these values in the given left hand side expression, we'll get iota power n into 1 minus p2 plus p4. This is the real part. Similarly, we have the imaginary part as minus iota times p3 minus p5 plus p7 and on taking minus 1 common from each of these brackets, we'll get minus 1 power n. This becomes a minus iota, b minus iota, c minus iota up till k minus iota. This we take as the first expression. Now in the original expression, which was x power n plus p1 into x power n minus 1 up till pn is equal to x minus a, x minus b up till x minus k. Initially we put x equals iota, now we will put x equals minus iota. So this becomes minus iota power n plus p1 into minus iota power n minus 1 up till pn is equal to minus iota minus a minus iota minus b up till minus iota minus k. And on taking minus 1 sign common from each of these n brackets, we will get minus 1 power n a plus iota, b plus iota up till k plus iota. Now dealing with the left hand side of this expression, we will get, on taking minus iota power n common from all these brackets, we will get minus iota power n into 1 minus P1 P2 plus P4. We just need to repeat the steps as we did earlier in the case of x equals iota plus iota times P3 minus P5 plus P7 is equal to minus 1 power n a plus iota b plus iota up till k plus iota. This we mark as the second expression. Now very clearly, if we multiply the expressions 1 and expression 2, what we will get as this a minus iota into a plus iota. This becomes a minus b into a plus b, which is a square minus b square. A square and iota square is minus 1. So this becomes a square minus minus 1, which is equal to a square plus 1. This becomes minus 1 power 2n, which is equal to 1. So this becomes the right hand side of the expression becomes a square plus 1, b square plus 1, c square plus 1 up till k square plus 1. The right hand side will become a square plus 1, b square plus 1 up till k square plus 1, and the left hand side of the expression, this becomes iota power n into iota power into minus iota power n. When these two get multiplied, and here we have a plus iota b and here we have a minus iota b, so this becomes a square minus iota square b square, which is a square plus b square. So this becomes 1 minus p2 plus p4 whole square plus p3 minus p5 plus p7 whole square. So on equating the LHS and RHS, we get a square plus 1 into b square plus 1 up till k square plus 1 is equal to 1 minus p2 plus p4 whole square plus p3 minus p5 plus p7 going up till the last term whole square. And this was the desired result which we needed to prove.